In this section, we're going to concentrate on finding the zeros of a polynomial function. Now, if you're talking about a polynomial function of degree 2, like a quadratic, well, it's very simple. You could use the quadratic formula if you're unable to factor it in your head. But frequently, with degree 3 polynomials or greater, it's very hard to find the first root or the first zero, which would help you finding the first factor. So we're going to be dealing with degree 3 and up polynomials and trying to find all the zeros. Okay, to start off, a polynomial function can have real zeros, so zeros that are on the real number line, which means they're either rational or irrational numbers, as well as non-real zeros. Remember the only numbers we've talked about that are not real numbers? That means they're complex numbers. And we won't do too much with that other than the first example with complex numbers. So let's find the zeros and their types, meaning rational, irrational, or complex, of the following polynomial. And since it's factored, it's going to be very, very simple. So all we need to do, it's already factored, and what does that number help us with? Nothing. It doesn't change the answer whatsoever. Because remember, what we're doing is setting that equal to 0, and we're finding the zeros. So you could divide both sides by -2/3 or multiply by -3/2, and that just goes away. So what we end up doing is setting this equal to 0, that every factor gets set to 0. So from this factor, we see that if x minus radical 2 is 0, then x equals radical 2. Radical 2 is a 0. And in this one, -1 would be a 0. From this factor, it would be 3 minus 2i. All I did is add 3 to both sides and subtract 2i from both sides to get x by itself, and we obtain this number. And the last one, we get add 2 and add I. So these are the 4 zeros of this factored polynomial. And maybe just as a review, what are the multiplicities of these 4? Well, notice that the exponents are all 1s except for this one. So the multiplicity would be 1. It'd be 2 for this one because of that exponent. X plus 1 really shows up twice. X plus 1 times x plus 1. And then the multiplicity for these would also be 1. Okay, well, this was very simple. The tough part is getting polynomials that are not factored. That's the tough part. And here's our first tool we're going to use. The Rational Zero Theorem. Okay, suppose we're given a generic polynomial that looks like this, with integer coefficients, which all of them will be that we deal with, and p over q is a rational 0 of f. Remember, we didn't really, maybe I'll review real quick what rational numbers versus irrational numbers. Remember what a rational number is? It's a number that can be written as a fraction where the numerator and denominator are integers. Obviously, the denominator can't be a 0, but they can be positive or negative. It's basically, just think of them as positive or negative fractions where the numerator is, here's a better way to say it. The numerator is an integer, which includes negatives, and the denominator is a natural number, 1, 2, 3, 4, ... Irrationals can't be written like that. And when you take an irrational in decimal form, it never terminates and it never repeats. Every rational number, when written as a decimal number, will either terminate or repeat. And then, of course, complex numbers have I in them. Okay, so say that p over q is a rational number that happens to be a 0, so it could be 1 over 2, 3 over 5, negative 6 over 7, something like that, and it's in lowest terms. Well, that means that p is a factor of this number right here, the constant term. And q, the denominator, is a factor of this number, the leading coefficient. So informally, the possible rational zeros of the function f are taken from the factors of the constant term on top, the factors of the leading coefficient on the bottom. Every possibility that there is, and that includes plus and minus. All right, so another way of saying it, if f of p over q is equal to 0, then p divides or goes evenly into the constant term, which is a 0. And q divides the leading coefficient, which is a sub n. Okay, that's pretty theoretical. Let's put this to work. It's pretty easy to remember after you do it once or twice. List all the possible rational zeros, and by the way, I'll frequently refer to possible rational zeros as PRZs. List all the possible rational zeros of this polynomial function. Well, notice that everything in the middle here makes no difference. All I care about are this number and this number. So the factors of 6 over the factors of 2, and you must include plus and minuses. I left off the minus intentionally because we have to include plus or minus. So what I'm going to do is put plus or minus out front, and then I'll put in parentheses. Well, let's see, a numerator and denominator. The factors of 6 are 1, 2, 3, and 6. And the factors of 2 are 1 and 2. Okay, so on an exam, I'm going to want you to write them all out. Write out every number, not in this format. So let's see what we've got here. The first thing I'm going to do is take all of the numerators and put them over 1, which that's easy because that's not even a fraction then. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. May run out of room here. That's every one of these 4 put over 1. Now I need to put all these 4 terms over 2. Now notice we will have some repeats here. For example, 1 over 2 we certainly have to have. So plus or minus 1/2. Now, what's plus or minus 2 over 2? 2 over 2. That's 1. Plus or minus 1, we already have it. Plus or minus 3 over 2. If I can squeeze that in, I'm going to put it down below. Plus or minus 3 over 2, and then plus or minus 6 over 2, but that's just plus or minus 3. So this is all of the PRZs, all of the possible rational zeros. Now, how would you find the actual zeros? How do you know which of these it is? Well, we don't know yet, but this sure limits it. I mean, if you just had to guess all the integers, there's an infinite number of integers. We've just narrowed it down to 1, 2, 3, 4, 5, 6. 6 times 2. We just narrowed it down to 12 possibilities. So if we were just looking to find one of them, we've narrowed it down to 12 possibilities, and we could test each one of them, which we'll do in the next video.